Hello and welcome to the Let's Talk Azure podcast with your host Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Microsoft 365 focused IT security professionals. It's episode 3 of season 4. Alan and I had a discussion around Azure Functions recently. With serverless and microservices application architectures rising in popularity, we discussed this newer development approach. Here are a few of the things that we covered. What is serverless and what benefits does it bring? How Azure Functions compare to other Azure-based serverless solutions, the costs of Azure Functions, and the languages and hosting options that are supported. We've noticed that a large number of you aren't subscribed. If you do enjoy our podcast, please do consider subscribing. It would mean a lot to us for you to show your support to the show. It's a really great episode, so without further delay, let's get started. Hey Alan, how you doing?
Hey Sam, not doing too bad. How are you?
Yeah, not too bad, thank you. Not too bad. It's been a busy week, and it's back to podcasting, so it's episode after episode at the moment, isn't it?
Yeah, definitely. It's definitely been busy, and I'm still probably partially recovering from last week and my my chat that I did in InfoSec.
Oh yeah, how did that go?
It went really well, actually, considering. I thought it was going to be more stressful than it was. I think it's fair to say.
Okay, yeah. So, did you have a lot of people attending and listening?
Yeah, it was packed. Yeah, with people standing as well, so it wasn't a short crowd. So
Good, nice. Yeah, that's really good. I wasn't there in person, but I've heard really good feedback. So yeah, well done for it. More to come for sure.
yeah, thanks. Well, I think podcast has helped with talking. So
Yeah, definitely. Yeah, definitely.
okay, so shall we crack on with this episode?
Yeah, let's do it.
Okay, so should we start with an overview of what serverless is?
Yeah. Okay. Yeah. So let's take it right back actually and start from sort of application development really. So web applications are primarily driven by APIs, and more specifically, really REST APIs. Well, web applications are. So what a REST API does is it is an interface for developers to essentially communicate programmatically with each other. So, if I've got some sort of code that I want to expose to, say, Alan, I'll create an API for it. I'll tell Alan how to communicate with it, and then he will consume my API. We'll effectively build a contract between each other, which is our sort of schema for our API. And Alan knows how I'm communicating, and I know what formats Alan wants data in, basically. And what's happened over time, and I'll just talk about web development for the moment, is that what we used to do is we used to build these, and we still do, to be fair, is build web applications or web APIs in monolithic applications. So all of our different API calls and everything would be bundled into one code base, so to speak. So one application. And then typically what you do is you'd then deploy that application onto some sort of infrastructure. So let's say a web server as an example. So let's say you built a C# web API application that just exposed a bunch of APIs. You might then upload that to IIS or app service in Azure for hosting. And that's one way of doing APIs and web development. But sort of a more a newer approach is around effectively microservices architectures. And what that is once those applications get to a certain scale, they can become unmanageable. So, imagine if you had 100 Allens. Well, that'd be pretty cool, wouldn't it? Have 100 Allens building API, consuming APIs, and 100, Sams, creating APIs. What can then happen is because that one application becomes so big, you can have issues with, say, deployment. So when one team wants to roll out a new version, they may be blocked by another team because there may be commits that haven't passed QA yet that need to go ahead. There's potentially many different things going on there. So what some organizations do is they have sort of a microservice architecture where I'll use a very basic example. Say it's my responsibility. I'm the addition guy, right? So I've got an API, you pass it two numbers, it adds them together and returns you the result. A very simple piece of business logic. Now, that traditionally might be baked into your monolithic application as like a module, like a class library that you then import and use. But in a microservices architecture, and you wouldn't for addition because that's ridiculous, but it's just a simple example. But in a microarchitecture, architecture, I would create an API that I would publish as a microservice, and all it does is do that addition. It doesn't do anything else. So I'm almost a tiny cog in the bigger machine, if that makes sense. Now, there's some benefits and obviously some drawbacks to that. Is one of the big benefits is different owners are responsible for just very narrow business logic. They can build in the technologies that they want to build in because we all talk APIs, basically REST APIs. We can communicate with each other because we understand that language that's common between different systems and programming languages. So I could be a C# developer, and Alan could be a Python developer. And as long as we both talk the same language to communicate with each other, effectively how we build is immaterial to each other. That can help in really large organizations because, you might be a C#, a traditionally like a C#, development organization. But in your local area, you might have gone through all of your C# developers. You might not be able to find enough of them. So some organizations have, different languages being used to spread technical knowledge, across different teams. So there's a few reasons, and really the main reason is that, that split architecture and split separation of concerns. So you're only concerned about what you're publishing and you're doing, and other people are, managing the concerns of other areas. Now, one of the challenges with a microservices architecture is orchestration and management of them. So instead of hosting one application, you might have to host 100 applications or 1,000 applications. These can scale into thousands or tens of thousands of, very small but discrete pieces of business logic. And that's kind of where the notion of serverless. There's a few ways to approach this. Right, this is just one of them. But serverless platforms sort of spawned out of this. And effectively, what a serverless architecture allows you to do is you write your code to do your thing, and then you give it to somebody to host for you and to manage automatically. So if another example of a serverless architecture is logic apps inside of Azure. It's not code. Well, it kind of is because it's kind of a mix of, declarative, user interface and code snippets inside of it. But effectively, in logic apps, you design your business flow, and then you upload it. Well, you don't upload it. You do it in the interface. You save it, and then Microsoft in Azure hosts it and runs it for you. And that's really powerful because in that serverless environment, you don't have to configure the web server. You don't have to, manage the operating system that web server runs on. You also don't need to manage, your deployment pipeline potentially to it because there's a lot of tooling in and around that. Because in logic apps, you just edit it in the interface. There's no publishing of code, right? And logic apps is great. There's nothing inherently wrong with it, but there's obviously a lot of developers out there that want to be able to create these discrete units of business logic, but actually declare it with code. So they want to be able to write in their languages, but also hand that code to Microsoft, at Azure, I should say, to host for them. And effectively, that is the major benefit of serverless, you upload your code, and then in theory you forget about it. Well, you forget about the management of that code and the hosting of it, because it's at such a high level. This is a platform as a service, but it's really, really high on that, on that sort of pyramid of, IaaS, well, bare metal to SaaS, because you're giving Microsoft your code, and you're telling it how to run your function and what it does, and they orchestrate that for you. Now, I have talked about APIs because that's a very popular use case for functions, but functions can also be for other things. So it could be a timer trigger that runs. Let's say you want to download an XML file from the internet, process it, and put it in a database once every hour. You could create a function with a timer trigger, and what that would have basically allowed you to do is say, hey, I want to run this every hour, and the system will orchestrate that running of that function for you automatically. Now, if you come from a logic app or a flow perspective, that's not going to seem too complicated to you, because that's part of those serverless systems. But if you're building, say, custom software, the management of those timer jobs, making sure that they complete correctly, they garbage collect correctly, and they execute correctly, can be a challenge. And that is one thing that serverless really takes away from developers and also system administrators.
Okay, great. So I think you were talking about the responsibility sort of table that you can get around bare metal, IaaS, PaaS, SaaS, etc. And because these serverless solutions are at the sort of PaaS level, and you said like the higher level of that sort of PaaS, you don't have to worry about the OS, whether it's running or not, etc., because that's all managed by Microsoft, which means from a security perspective, you don't have to worry about patching it, because it's automatically done by Microsoft and etc. So you don't have to worry about vulnerabilities in the operating system side of it, and maybe your core, maybe your core language side of things, maybe. But yeah, and then you've got your vulnerability and stuff that you may have in your code. But that might tie into the whole DevOps thing we were talking about the other day.
Yeah. So from a vulnerability management perspective, you've got because logic apps wraps you in cotton wool even more than function apps, right? It's going to do a lot of that. You effectively can't define the versions of modules that they use under the hood, and for their parsing and all of those types of things. So you still have to manage your third-party dependencies that you've got inside of your code. You might use NuGet, or you might use npm to bring in packages and other open source tools potentially, or maybe your own tools. So you have to manage that. So that's where a Defender for DevOps comes in, because it would help you with that scanning. But then you also need to think about your threats in terms of web application development, things like SQL injection, cross-site scripting, things like that. You've still got to handle a lot of that for you, for yourself, if that makes sense, because you do have a lot more flexibility in what you are able to do by yourself.
Yeah, absolutely. Okay, so Sam, you kind of mentioned them just a minute ago, but what are Azure Functions?
Yeah. Okay. So I suppose we've gone into this quite a bit anyway. But what Azure Functions is doing is it's taking, it's allowing you to run functions, code functions, in a serverless environment. So you can define a number of functions in the language of your choice. We'll talk about languages further on. You effectively upload your code. You can upload multiple functions inside of sort of one function app, And you can do things like, process file uploads, processing data, running scheduled tasks. We talked about web APIs. You can also set triggers to respond to database changes and things like that. So if you are in sort of the Flow and Logic Apps world, a lot of those triggers are going to be quite similar to you because it's the same type of platform. You're just managing the code yourself, basically. So effectively, what I do is I write my code. I would assume that you would check it into some sort of source control and then upload it into Azure Functions. And then it's going to upload. They're going to verify it. There are some configuration files that wrap around your code. So let's say you're writing C#. There's a way to set your entry points for the functions and a config file describing how the function works, basically. So there is a little bit of difference between a straight web API project in C# in functions. There's also some things you can and can't do with functions. So, if you're thinking about porting in an application that you've got already and splitting it apart, you need to think about how certain things work. And these functions, they have a maximum memory consumption of 1.5 gigabytes. And we'll talk about pricing and cost because the way that pricing is calculated on the consumption model is a little bit more complex than other systems. But effectively what you do is I think you can, I'm not sure the exact max execution time for consumption. I want to say 5 minutes. That might be wrong. Don't quote me on that. But there's a max execution time. And you can effectively use up to 1.5 gigabytes of memory, and you can run for any period of time up to that max execution time. So what that effectively allows you to do is just code, upload your functions and then run them, and all of that. There's no containerization from your perspective. There's none of that management. It just hosts it for you automatically.
Wow, I mean that sounds great. Not having to do too much to get them going. Like you said, there's a bit of additional config to sit on top to tell it how to operate, but outside of that, you just write your code like you would normally. So I think we kind of covered this actually, but how are the Azure functions hosted in Azure?
Okay, so there's a few different ways, and I'm going to call it out that the vast majority is probably going to be consumption. So like a Logic app is building consumption, right? So for every run that you do, you are charged for the number of actions that you perform in Logic apps. A little bit different on billing on that, but effectively you just pay on Azure Functions on the consumption plan, you just pay per execution. And it's basically a balance of the I'll give you some specific examples later on, but it's like the number of time. It's the number of time times the amount of memory that you use effectively to get your gigabyte seconds of memory that you've used. So each one individual run will cost a certain amount of money, and then you just pay for the number of runs that you actually execute. So what's great about that is that you only pay for when your functions are running. One of the hardest things with any web application is if you've got an application that let's say it's just a timer job that wakes up every hour, and let's say it's not business critical. Let's say you're automating something, right? And it wakes up every hour. If you were to run that traditionally, you'd have to have a web server running like 24/7. The web server doesn't boot up, does it, to run its task and shut it down. It just stays on all the time. So things like app service, there are cheaper tiers, but you basically have to pay for an app service instance running constantly. Whereas the consumption, you can still write code, but you can only be charged when it actually executes. And also you get the benefit of being able to scale automatically as well, because you're not provisioning virtual cores and memory. You haven't got unlimited scale, but if you do need to scale up, there's no instances to scale up. It's effectively the the platform itself handles the execution of that. One of the downsides of serverless functions is they can take some time to warm up, should we say. So if you think your function is going to execute and then it's not going to exist anymore, but when it boots up, it's got to load like, the binaries into memory that you're going to use, right? So, if you include JSON.NET because you do some JSON parsing, it needs to load those DLLs into memory basically at that time, and your application's code. So what you can have is on a cold start, you can have a few, usually hundreds of milliseconds of startup delay, and that can sometimes be an issue for certain applications. So what you can do is you can go onto a premium plan, and a premium plan allows you basically provision virtual cores and memory to an instance that's running 24/7 basically. So you don't have to wait for any of that execution to occur or that warm up to occur. You can then just start running straight away. It's also probably worth pointing out now is that a premium plan allows you to also do things like custom Linux images and things like that of what you're actually running on, because you've got an instance running there basically. And even though every single execution on the consumption plan is very cheap, is actually quite expensive resource. If you were to absolutely hammer the consumption plan, you would start to incur a lot of cost. Whereas the premium plan, you might get better economies of scale with provisioning an actual virtual core for you to run on. And then there's a dedicated plan as well. So what you can do is you can run it within an app service plan that you've currently got. So the premium plan is effectively having its own sort of Azure Functions plan, but you can actually embed Azure Functions into app service plans as well. So you get the predictive scaling and costs, but you can also attach it to sort of underutilized virtual machines that app service plans are currently running on to like sort of bolt them onto the side effectively.
Okay, cool. So there's probably like a tipping point at some point then between consumption versus premium versus dedication. At some point from a cost perspective, maybe from a resource perspective, if you're hammering it too hard or you need it to be instantly there kind of thing. And we've seen, or I've seen at least, a lot of consumption used in our sort of day-to-day, kind of because we're sort of co-hosting them with Logic Apps. When we can't do what we want in Logic Apps, we jump out to Function Apps to write the code, because sometimes you can do it quicker.
Yeah.
Or simpler, I should say. Simpler. Yeah. Okay, so the kind of three plans, like you said: consumption, premium, dedicated. What's the sort of costings around those then?
Okay, just before I jump onto that, I did just miss one bit out there as well, is that you can also host functions not just inside of what I just described. There's also the ability to host them inside of Azure Container Apps as well. I believe that's preview at the moment, I think, so that you can effectively isolate those functions running inside of containers, but hosted in Azure effectively. And that you can also do it on Kubernetes using Azure Arc as well. I believe that's also, or maybe that might be the one that's preview at the moment. So if you don't want to run, because in theory, then you could run it on bare metal, couldn't you? Because you could write Azure functions, which then get deployed to Kubernetes that could potentially be in your colo or in your data center, right? At that point, there are other ways to do microservices architectures with Kubernetes, but you might want, the end-to-end, ecosystem that Microsoft gives you, right? Because Azure Functions is well supported in Visual Studio Code, so that can help you with that. And that can, sometimes you might need customer hardware requirements depending on your environment. So yeah, that's something just to call out.
Okay, so that's probably, that scenario might also be around where you need to process data.
Yeah,
if you
definitely.
need to put it in another location.
Exactly. Yeah.
Okay.
You might have some really sensitive functions that you want to run, like on-prem, but you might want the flexibility of serverless and microservices, but not the headache of orchestration yourself. I mean, if you are running Kubernetes, you've probably got a bit of an ops. I'll call it a headache anyway, because it's not simple to run, basically.
Yeah. Okay. So I think they're doing something for that for Logic apps as well, which isn't this topic, but there must be they're kind of based on the same sort of.
Yeah, they can all go into apps. They can all be like embedded into apps, so it's all kind of the same thing.
Serverless technology, but different ways of
definitely
showing it. Yeah. Okay, so costs. How do you work out the costs, and is it free? Is there any free?
So the consumption plan, there's so the way it's billed for consumption is gigabyte seconds, right? So I'll try and use a very simple. I'll use a very simple example. Let's say your function app uses a gigabyte of memory, and it runs for exactly 1 second. To make it as simple as possible. Sounds like a pretty beefy function. Functions can scale from anywhere from 128 megabytes of memory all the way to 1.5 gigabytes of memory. So the minimum bill unit for the actual memory allocation is 128 megabytes. So, if you only use 16 megabytes or something like that, then you're still going to be charged for 128 meg. And then it's how much memory it used versus how long it used it for. So let's pretend in this scenario that it used the whole 1 gigabyte for 1 second to make the calculations as simple as possible. So for each run, you would use 1 gigabyte second, wouldn't you, of time? So there's two elements of billing. There's the execution time in gigabyte seconds and the number of executions. So there's a free grant of 400,000 gigabyte seconds. So in theory, you could run that function 400,000 times before you hit your free consumption. And also there is 1 million executions. So those 400,000 executions that we talked about would be covered as well. Then it's pay as you go. So I can't tell you the cost because there's so many zeros in front of it. 0.00016 dollars per gigabyte second, and then 20 cents per million executions. So I think I did rough maths as just a working example. A function that utilizes 128 megabytes. It was like basically a function that runs for 250 milliseconds. And a function running for 250 milliseconds is, unless you're calling out to another service and waiting for that response, 250 milliseconds is quite a decent amount of time. So you've got 250 milliseconds, and then I think I calculated it to I think it was 128 megs worth of memory that was used, because 128 megabytes of memory for a singular function action is quite a lot unless you're doing high amounts of data processing or machine learning or something like that. And then I think I calculated that 100 million runs of that would cost something like $42 or something like that. So, what we're really talking about is insane numbers and an insane amount of memory and resources being used before you start to be charged. I think it's worth calling out as well is there's no concept of CPU or vCore in consumption of function apps. It's all around the memory, because I believe that the amount of time it takes to execute is effectively your you're bound by the CPU that's there, if that makes sense, right? You don't provision like faster CPU or anything like that. Your function would just take longer to run, basically. I don't know the specifics of the actual, resources from a CPU perspective that you get access to. It does also create a storage account to host the code and bits and bobs like that. So there's that to cover. If you had a lot of resources that backed it, you might incur some storage costs, but they're relatively cheap. And then you've also got networking on top of that. So standard Azure egress costs and all of that sort of stuff. Then when you go on to the premium plan, you effectively can you run like what's the best way to describe it? You run an instance, or an instance inside your scaling plan. You have to at least have one running at any one time, but you can scale up to multiple. I'll call them scale units is probably the right term. But it's so you can go pay as you go. You can do 1 year and 3 year savings plans as well, so that you're effectively, because you're provisioning vCores, you can start to do that as well. But they are well, it depends what scale you're at, but they can be a lot more expensive than starting with consumption. You're looking at 1 year saving on a single vCore is $112 per month on a singular vCore. And memory is $8 per month per gigabyte on a 1 year savings plan. So if you do need to stretch beyond the 1.5 gigabyte limit, maybe that's what you need for your function, you're going to have to go to premium. But it does allow you to actually provision your resources and also grab some savings there. And I'd probably bet that, run for run, you'd probably get better value if you're absolutely hammering it on the premium plan, would be but I've never got to that level with function apps. It's probably worth saying, because consumption is just great, really. And then Azure Arc enabled Kubernetes is just free at the moment because it's in preview. So there's not really much to talk about there. And then when we talked about embedding it in app service, I think it would just be covered under your app service pricing at that point if you went down that dedicated route.
Okay, cool. The sort of free plan part, is that per function app or is that per subscription? I thought it was maybe across a subscription, that limit, but I might be wrong.
I would have thought it would be across subscription. I don't have that in my notes. Let me just check the. I'm going to say that it's per subscription, because it would be, because then you could just make as many functional apps if you want to. But that might be the case.
But yeah, it's still a lot of compute, a lot of actions that you can take even with that. Same thing with like what we've seen in Logic apps. There being a lot of runs on I think it's on the subscription, for actions and things like that.
Yeah, so. Get you building, get you invested in that platform, right? See the value of it at a really big level as well, right? Because we're not just talking about, you can, so yeah, it's a really good way to start, definitely.
Cool. Okay, so moving on, you kind of talked about choosing languages that you could use to to create your function apps. So what languages are supported?
Okay, so out of the box, there's C#, Java, JavaScript, PowerShell, Python, and TypeScript, which is kind of JavaScript, but it's not, but it kind of is. But then you can also wrap your own. What's the best? I think it's called a custom handler. So what you can do is you can build a custom handler, and in the docs there's examples of Go or Rust functions being created, and you effectively create a custom handler in the web server, to actually write your own effective starting point for the functions in a different like native language. It's hard for me to explain, but effectively what you do is you say this executable is the entry point for my functions. Go there to execute. So there's a couple of really good examples on the on the docs to basically be able to bind into Go and Rust. So I think what they've done there with that is the ability for, if you're not supported out of the box, but you do have other languages that you want to support, you can wrap around and utilize an actual native binary and system.
Okay, cool. There's definitely a lot of languages there that you can use. It's not limited at all, is it?
No,
really?
And it's got all the, I'm going to call it major ones, especially for like web application development, right? And a good mix of, more, I would say, like commercial and enterprise driven languages, like Java, your C#, even though like C# is now open source, right? But it's more enterprisey, background. And you've also got things like Python and also Node.js and JavaScript and TypeScript. So yeah, really powerful.
Cool. Okay, so what sort of scenarios can you develop for?
Yeah, so I think we've talked. We've mainly talked around. We've mainly talked about very simple scenarios, right? Like I want to upload a file. I want to process some data. I want to execute a single function or unit of work effectively. But if we take serverless to another level, let's call it, and we'll call them stateful functions. Now, when we might currently have, let's say we have 2 functions that we want to run. So we first do our addition, and then we feed our addition into something else, like a subtraction or something like that. What do we do there? Do we tell the addition function to then talk to the subtraction function? That might not be right, because sort of the chain of responsibility might not be there, if that makes sense. Because if I'm the addition guy, then all I care about is addition. I don't care about then calling the next function in the chain, right? Because one of my users might just want to do addition. The next one might want to do an addition and subtraction, if that makes sense, like chain functions together. And then what you've got to think about is do I introduce another function to orchestrate that, right? Which is completely possible. That's what you probably have to do. But that's actually built into functions. So what you can do is you can define stateful workflows by writing orchestration functions, which then uses entity functions to actually do the work, if that makes sense. So you can chain workflows together, but you chain them together, say, programmatically. You define how they communicate with each other. So we have smaller entity functions that are just discrete pieces of work. And then we've got orchestration functions, which actually do the orchestration of that work, basically. Now, what we're now getting sort of into, and I'm not going to go into it in depth because it's like a whole part of computer science, really. But I just wanted to call out that you can do stateful functions inside of Azure Functions, because it is a challenge when you're building these disconnected microservices to manage state and how the machine sort of works together, basically. So it's taking a lot of complexity away from developers and putting it in the platform, basically.
Okay, cool. Thanks. Okay, so we kind of talked about egress stuff, pricing. So what is there for networking, handling the network?
Yeah, so similar to other serverless, products in Azure, in order to get full like VNet networking support, you can't be on the consumption plan, basically. So if you do have a private networking requirement or a specialized networking requirement, where I'm not even going to call it a specialized networking requirement because binding onto a VNet isn't particularly that special, is it nowadays? But if you need that level of control, you're going to need to be on the premium plan at a minimum, because the consumption plan isn't gonna give you that.
Okay, cool. So it's out on the internet in effect, or publicly facing kind of thing with controls in front of it, or about binding to your VNet for in effect internal or private network connectivity.
Yes, exactly.
Okay, cool. So how do Azure Functions scale? We kind of talked about the scale units. Can you go into a bit more detail?
Yeah, so obviously we get that great benefit with consumption apps. You've effectively not really got to worry about scaling at that point. And especially with a lot of public facing APIs, you can really struggle with scaling. If you're running, let's say you're an events company, you run online events, and normally nobody's logged into your system, and then ever so maybe everybody wants to order their tickets for a concert that's coming up. You could have thousands of people hit your website or something. With that consumption based approach, you're gonna get that scaling built in without you really having to do anything. It's completely Azure's responsibility to handle it from that perspective. And then you still get the ability to do scaling with the premium and dedicated plans. You just have to set some of those parameters yourself. If you want to auto scale, if you want to pre-provision, because that's a real benefit of any of these sort of PaaS systems is you don't sometimes even need to do auto scaling, because what you can do is you can just say, okay, the day before we're going to go and add 2 more scale units in, and we're going to run those for 2 days or 3 days, and then we'll shut them back down after we need them, because we could just pay as you go, right? So a lot of the time when I've worked on systems in the past, we've just 6 hours before the event happens, we go and bump all the servers up, just to make sure that there's no time to even scale. It doesn't matter if we spend a little bit of extra money over the next couple of days and scale them back down. You do have to remember to scale them back down though, because that can be dangerous, right? I haven't learned that from experience. Not so there's you still get all the benefits of app service inside of this as well. You're just handling even less of the web server, basically.
Okay, great. So is there anything else you want to talk about Azure Functions?
No, there's obviously a lot more to go into, really. High availability, data persistence, things like that. But what I wanted to do is just really try and sort of talk about the value of the serverless aspects of it, if that makes sense. Not sort of a technical deep dive into like actually writing the functions themselves. So yeah, if you're writing, especially if you're writing C# web APIs, do look at see if this is a viable hosting solution for you, because it can be very powerful.
Okay, great. Well, yeah, thanks. It's been a great overview. I think definitely in a deep, not necessarily a really big deep dive, but definitely a dive into what the capability is.
Yeah, definitely. Yeah, and I just wanted to call out as well. We've got a previous episode on Azure Static Web Apps, Season 3, Episode 10. And what you can do with static web apps is you can embed Azure Functions into your projects. So one thing I haven't really spoken about is single page applications. So static web applications. A lot of the time they are paired with serverless functions to do their APIs. And what you can do is you can sort of glue them together in a project and deploy them as one thing basically, with static web apps. I don't think we went into too much detail about Azure Functions in that episode. But if you are a web application developer and you've got a single page application like a React, a Gatsby, an Angular, a Svelte, a Vue, whatever your front end flavor is, look at that combination between serverless backend and static front end as well. That's a very modern and efficient way to deploy and build. So Alan,
right.
Next episode, I think it's your one next.
Yes, so I'm going to talk about Microsoft Defender for Cloud and the cloud security posture management, as that was kind of my topic at the InfoSec, so I'm pretty geared for it. So we might as well just do it. We haven't done an episode on it. We've talked about it, I think, in various episodes around Defender for Cloud, but let's talk about being able to detect misconfigurations and highlighting risks within your multi-cloud environment.
Okay, yeah, and that's a great. It's a great set of tools and sort of a great area, especially from the security side, right? There's a lot of value in gaining that visibility. So yeah, that should be a great episode for sure.
Yeah. So exactly. It's understanding what you don't know. Definitely.
Yeah, exactly.
Did you enjoy this episode? If so, do consider leaving us a review on Apple or Spotify. This really helps us reach out to more people like you. If you have any specific feedback or suggestions, we have a link in our show notes to get in contact with us.
Perfect. Thanks, Alan, and I'll catch you all on the next one.
Yep. Thanks all.